I'm Anil Kumar sharing with you two test questions on inverse of quadratic functions. Question number 1 here is, algebraically, inverse is found by interchanging x and y. Determine inverse of f of x equals to 2x squared minus 8x. Explain restrictions on f of x to make inverse as a function. So it has two parts. It's a communication question for you. Question number 2 is, sketch inverse of the given relation. So this is the graph which is given to us, a parabola opening right, and here is a line y equals to x which is going to help you to sketch inverse of the given function. I would like you to pause this video, answer these two test questions. They are basically communication questions, and then look into my suggestions. Now after this I'll take a few technical or application questions on inverse of quadratic functions. So let's see how to answer them. So the very first question here is, we need to find inverse of the given function. So we are given f of x as equal to 2x squared minus 8x. Now to find inverse, first step is interchange x and y. So let me write f of x as y. So we get y equals to 2x squared minus 8x. Interchanging means x equals to 2y squared minus 8y. Now that is the first step. So what we did here was we swap x and y, correct? Now we need to solve for y. Now how do you do that? So the only way to do is to complete squares. You may have to review this technique if you're not very sure of, but here is how you do it. So you could now write this as factor out the leading coefficient, which is 2, and then the remaining will be y squared minus 4y, correct? Now the real step for completing the squares is that you have to add and subtract what? Add and subtract half of 4, which is 2 square of that. So 2 square. Now this makes the first three terms as a perfect square, and so you could write this as y minus from there, 2 from this place, correct? And minus 2 square gives you 4. So that is the vertex form of your parabola, correct? Once you get the vertex form, then it is simpler to find the inverse. So first step is to get the vertex form. So let's rewrite. So we have x equals to 2 times y minus 2 whole square minus 2 times 4 as 8. So don't forget to multiply 2 with both. Now we can isolate y. So we'll bring 8 to this side. So we get x plus 8 equals to 2 times y minus 2 whole square divided by 2. So we get x plus 8 divided by 2 equals to y minus 2 whole square root. So whenever you square root, you have to do plus and minus. Don't forget this part, right? It's another critical part of this solution. Now bring down 2 this side. So we get plus minus square root of x plus 8 divided by 2 plus 2 equals to y, right? So you can now write that the f inverse of this particular function is equal to, we are not writing x since this is not a function. We got here plus minus 2 values. Do you understand? X plus 8 divided by 2 plus 2. Now to check whether this is the right answer or not, we can actually see how it works backwards. So forward, we have to multiply y minus 2 whole square, then subtract 8. So backward, you have to add 8, divide by 2, then do square root and add 2. Do you see that? So it works perfectly fine. So that becomes the inverse of the given function. So that is the first part of this. The second is explain restrictions on f of x to make inverse as a function. So what you notice here is that inverse is plus minus 2. So what you could do here for part 2, restrictions. You could take either side of the function, right, from the vertex. So the vertex here is at 2, right? So we could say that let x be greater than equal to 2, correct? So that gives you a restriction. So basically, you're only looking into one part of this particular parabola, which is, let's say it was like this. We are looking only the positive part of this. I mean the right side of parabola from 0. You get an idea. So once you restrict, then your inverse function will be written as, let me rewrite inverse function. Now it becomes a function. So I'm writing f inverse of x. This will be equal to, if you take the right side, you have to take the one part with positive. So that is square root of x plus 8 over 2 plus 2. You get an idea. So which, when you sketch, will be kind of like this. The upper half of the parabola opening right. Do you see that? So what you get here is this opens up. This one opens up, right? So we have open up, and this one is to the right. So if you take x greater than 2, we are looking into parabola which is on the right side, and the inverse is the upper half of the parabola opening towards the right. Do you get the idea? So that is how you find the inverse, and making these restrictions will help you get inverse as a function. Reason being that now if I draw a horizontal line, it only intersects at one point because we are not considering this one. Do you understand? That is the reason. So explain the restrictions. That part is kind of important to understand. So now if you restrict, then it passes horizontal line test. Okay, so that is the reason. Now let's move on and take the next question, which is to sketch inverse from the given function. Now let us see how to sketch inverse of the given relation. So we are given a parabola which is opening right. So this is the right side, right? So we are given a parabola, let's write down, which opens right. So for the inverse, what do you expect? Inverse will be a parabola which opens up, right? So that is one thing very important. Second, we know this is the line which is y equals to x. So wherever the line crosses the parabola, those are invariant points, right? So y equals to x. So we have two invariant points here. The other critical part to look into is the vertex itself. The vertex of this is at -3 and y value is 2. So on the inverse, the values will swap. We get 2 minus 3. So at 2, we have 1, 2, 3. So this value, which is 2 minus 3, will become the vertex. Now once you get that and you have this invariant points, it's kind of simpler to sketch the parabola. But I hope you have got the idea how simple it could be. Perfect. Now let's see how to get other points. Now if you move one step, right? So this is like one step, and then next time it is 3 steps, 1, 2, and 3. That means the steps taken are 1, 3, 5, and so on. That means A is equal to 1, right? So this is from the steps. So those of you who understand steps, for them this sketch which I'm going to sketch now will be very simple. So we'll move one step, and then next time we'll use 3 steps, correct? And from symmetry we know 1 step, and next time 1, 2, and 3 steps. That makes sense. Now when I sketch, we have to go through this. You get the idea. And then 5 steps. So 1, 2, 3, 4, and 1, 5. And similarly on this side, 1, 2, 3, 4, and 1, 5. You see how accurately I could now sketch the graph. Just with very few points and so quickly. Joining these points with a smooth curve. So this is very important. With a smooth curve, we get inverse function. Now inverse is a function in this case since it passes the vertical line test. You see that these points should have been overlapping. These are called invariant points, correct? So these two points are invariant points. Let me write. Since they are common to both the graphs, correct? They don't vary. They lie on the line y equals to x. Now let us extend this question, right? Let's extend and write the inverse function equation, correct? Clearly, the inverse function equation here is, we are given the vertex at 2, so it is x minus 2 whole square minus 3. And as you can see, the domain for this function is x belongs to real numbers, and the range is y belongs to real numbers, where y is greater than or equal to minus 3. So I hope that helps to understand the whole situation. Perfect. Feel free to write your comments and share your views. After this, also look for my videos where we are talking about some application and thinking questions on quadratic functions. If you still need to know some concepts about inverse, look into our video, for which I'm placing a link here. Thanks for watching and all the best.